Boyle's law states that if temperature of an ideal gas is held constant, so the temperature is held constant, that the pressure of the gas and its volume satisfy the relation P is equal to K over V. So temperature is held what? Constant. So we don't even have to worry about that. So we got P equals K over V. Can anybody tell me what kind of relationship this is? Pressure to volume? It's an inverse relationship because it's K divided by V and not K times V. So we got P is equal to K divided by V. K is constant. Which of the following best describes the relationship between the rate of change with respect to time of the pressure and the rate of change with respect to time to the volume? So they want the rate of change of pressure and volume. So we're just doing the derivative implicitly. So what you might do is, instead of using quotient rule, is move the V where? Make it V to the negative 1. Okay, way easier. No way I'm doing quotient rule on this. Okay, so we're going to get dP dt is equal to negative K V to the negative 2 times dV dt. So then my derivative will be dP dt is going to be equal to negative K over V squared times dV dt. So the answer would be D. That one's pretty easy. Now you know. Yeah, you just have to get used to taking your time and reading through these. All right. Let x and y be functions of time such that the sum of x and y is constant. Okay. Which of the following equations describes the relationship between the rate of change of x with respect to time, so we know it's a related rate problem, and the rate of change of y with respect to time? So let x and y be functions of time such that the sum of x plus y is constant. Okay? All right, well, I don't have to worry about that. So I'm just saying that's the equation, the sum of x plus y. So x plus y is what? Is equal to k, a constant. Okay? So let x and y be functions of time such that the sum of x plus y is constant. Which of the following equations describes the relationship between the rate of change of x with respect to time and the rate of change with y respect to time? All right, let's just do the derivative. So it'd be dx dt plus dy dt is equal to a constant. What's the derivative of a constant? 0. So obviously c is out because when you do the derivative of constant, it's 0, and d is out. So really, it's just they're saying what's the relationship between the rate of change of x and the rate of change of y. So they want you to basically set them equal to each other to see what the relationship is. So it's going to be dx dt is going to be equal to negative dy dt. They're opposites of each other. So the rate of change of x is the opposite of the rate of change of y. And that's how they'll be held. That's how the sum of x plus y would be held constant. Okay? Any questions? That was pretty straightforward too. All right. The right triangle has a base x meters and a height h meters, where h is constant, so I'm going to circle that, and x changes with respect to time measured in seconds. The angle theta, so and a right triangle x and a height h meters where h is held constant, so h is constant. X is the only one that changes with respect to time. The angle theta is measured in radians, is defined by tangent of theta is equal to h over x. Which best describes the relationship between d theta dt, the rate of change of theta with respect to time, and dx dt, the rate of change of x? And remember, h is held what? Constant. So we have tangent of theta is equal to h over x, and h is held constant, correct? Okay? So h is held constant. So we don't have to do the derivative of h. We can just treat it as a what? As a constant, okay? So I'm going to do the derivative of this implicitly, okay? So we've got tangent of theta is equal to h over x. All right. Interesting. This one's actually kind of hard. All right, so we're going to have to do the derivative of this. Whew. Yeah, this one's going to be tricky. I gotta think about this a second to make sure I don't screw this up. All right, we're gonna get, yeah, that's gonna be fun. We're gonna have to imagine, so we have a right triangle. We need to imagine the right triangle. I need to actually draw a picture for this one. I see what we're gonna have to do. This one would be tough, but once you see it, the next time around it won't be as bad. All right, so we have an angle theta measured in what? Radians. We have the height of the triangle, which is held what? Constant. So that's never going to change. So we're actually going to be able to take the derivative. When we get to the derivative of h, what's the derivative of h going to be? 0, okay, because it's held constant. All right, we got x that changes, so we're going to have a dx dt. We're going to have a dx dt and a d theta dt. And then we don't know the hypotenuse, but I can find the hypotenuse, and I'm going to need it because when I take the derivative of tangent, what's the derivative of tangent going to be? Secant squared. So I'm going to have the ability to figure out what secant is, okay, in terms of h and x. So I know that this is a x. I know this is h. I know SOHCAHTOA, okay, SOHCAHTOA. All right, and just hang on to that. I'm going to go ahead and find this hypotenuse real quick so we're out of the way. So the hypotenuse, we'll just call it, what do you want to call the hypotenuse? We can't call it h. Fine, z. I like z even better. Okay, typically I use y for the height, so z or r. In trig, you always did r for the hypotenuse, so you could do r if you wanted to, but I usually go to z if I need to, if I don't want to use another variable. So we're going to have x squared plus h squared is equal to z squared. I would need to know what z equals in terms of x and h. Okay, so I'd solve for z. So z will be the square root of what? Do you see it? So z would be the square root of x squared plus h squared. Is everybody okay with that? So when I get to that point, if I need the hypotenuse, and I think I'm going to, because I'm going to have to do secant, it's x squared plus h squared. Square root of h squared plus, square root of x squared plus h squared. Is everybody okay with that? All right. So I'm going to do the derivative. So what's the derivative of tangent? Secant squared theta times d theta dt. Now, h over x, we actually don't need to do quotient rule because h is what? So I can make that hx to the -1. Do you agree with that? So then I don't have to use quotient rule because h is constant. And if you want to change h to a k, you can, but I'm not going to because they told us h is constant, so I'm going to treat h as the constant. So we're treating h like we would k usually. All right, so it's going to be negative h x to the -2 times dx dt. And they wanted you to solve for it. Look at all these. They're all solved for what? So we're going to have to solve for d dt. So we're going to have, we're going to divide by secant squared. So we'll have d theta dt, and I'll show you how to deal with the secant squared because obviously it's not in your problem. So we're going to have negative h over x squared times secant squared theta because I divided both sides by secant squared theta times dx dt. Is everybody okay with that? I want to stop right there. So what I did is I moved the x squared to the denominator, left the negative h, and I divided both sides by secant squared. So the secant squared will go on the bottom with the h squared. Is that okay? Now, we can find secant. Secant is the reciprocal of which one? Sine, cosine, or tangent? Cosine. So we know cosine, so SOHCAHTOA. We know cosine is adjacent over hypotenuse. So what's secant going to be? Hypotenuse over adjacent. Well, we happen to know the hypotenuse. So secant, I'm going to write it over here. Secant theta is going to be hypotenuse. What's the hypotenuse? Square root of x squared plus h squared over the adjacent. What's the adjacent? If here's theta, which one's the adjacent? X. So we can replace secant with that, but we want secant squared. So what is secant squared going to be? What happens if you square all this? Gets rid of the root, so you'll have x squared plus h squared over what? X squared. X squared. So there's my secant squared. Now when I replace secant squared in the denominator, it's really going to do what to it? Flip it. It'll be a reciprocal. So what will go to the top, actually?
X squared.
The x squared. What will go to the bottom? The x squared plus h squared. So I replace the secant squared with x squared plus h squared over x squared, but since I put it in the denominator, I flipped it. Now what happens to the x squareds? Cancel. So we're left with negative h over x squared plus h squared times dx dt. Let me write that down. We're left with negative h over x squared plus h squared times dx dt. This is a good one. I like this problem a lot. And that obviously is answer what?
That's not right though, because that's what I put, but it's B. Mine says A is correct. Oh, really?
A is correct.
Are you on
Are you on number 3?
Oh, yeah.
Okay.
Been there.
That's okay. And sometimes I do miss some. Not very often, but anyway. But I do miss some. All right, next one. This one's, now they're going to kind of do a repeat. So the second time around, this should kind of solidify things. In a certain, and again, I think the hardest thing is kind of reading through all this, right? In a certain factory, assume the number of workers is what? Constant. The number of minutes it takes to make a single product and the number of units of that product that are made per day satisfy the relationship where U is equal to K over N. So again, what kind of a relationship? Inverse, where K is constant. And they don't even worry about, we're assuming that K value is the number of workers. Okay, but I don't have to worry about that. K is whatever, it's constant. All right, which of the following best describes the relationship between the rate of change of U and the rate of change of N? So I got to do a derivative implicitly with respect to time, so it's a related rate problem. So I'm going to have U is equal to K N to the negative 1. So I'm going to have du dt is equal to negative K N to the negative 2 times dN dt. So final answer would be du dt is going to be equal to negative K over N squared times dN dt. So what answer is that again?
D.
Is it D again? Wow, they're really interesting. Okay, is that okay? Pretty straightforward, right? All right, number 5. Again, same thing. Let functions x and y be functions of time such that the sum of x and twice y is constant. So how would I write that equation? X plus 2y equals a constant. Okay. So again, let x and y be functions of time. So when it says functions of time, it's like x of t and 2y of t. But again, we don't have to worry about t because we just do that implicitly always. Time's not really going to show up in the equation. So we're going to have, and again, it's the sum of x plus twice y. X plus twice y. The sum. Sum means add. So we're going to have dx dt is going to be equal, or dx dt plus 2 dy dt is equal to 0 because that's constant. And I want to see the relationship between x and y. So let's see here. It's not c because it's supposed to be, so it's not that one. It's not d because when you take the derivative of a constant, it's 0. And it's not a because you're going to have to subtract. So the answer is definitely going to be b because you're going to subtract the 2 dy dt over. So dx dt is equal to negative 2 dy dt. And again, I like these because we didn't do a lot of trig ones. So again, probably going to be a trig one on the. This stuff's supposed to mirror what the AP exam is going to look like this year. So might be a trig one on. Now, does that mean we're not going to have a volume one? I guarantee you're going to. I mean, I almost always see a circle or a sphere or a volume one as either a multiple choice or a free response. So that's going to come up. That's pretty standard. A right triangle has a base x feet with height h feet where x is held constant and h changes. So this time, x is held constant. With respect to time, let the angle measured in radians per second be defined as tangent theta again is equal to h over x. And again, x is held.
Give these guys a break. Oh, you did break donuts. Okay.
I did.
Just checking to make sure
Yeah, I'm taking care of them.
better.
Yeah,
You look tired though.
I do.
It's Friday, guys, come on.
Been a long week, getting the grind on.
I'm impressed you're here.
I know. I was here yesterday too. You were impressed.
I wasn't.
Got back at
I'm impressed every
1:30.
day he's here not showing movies.
Have we ever watched a movie? I don't think so. My first hour does, though. All right, tangent theta is equal to h over x. Which of the best following describes the relationship between d theta dt with respect to time, dh dt? So h is held constant this time. So again, we're going to do that right triangle. And this is x and this is h. And I'm going to cheat because I already had it done from last time. What was it? It was the square root of what? X squared plus what? H squared. That was that hypotenuse, and we found that with Pythagorean theorem. Okay? So that's already done for us. So when we have to do secant here in a minute, we got it. All right, so the derivative of tangent is what? Secant squared theta times d theta dt. This side, h, we can think of this as 1 over x times h, because x is held what? Constant. So you're just going to treat 1 over x as a constant. So then the derivative of 1 over x times h would just be what? Think of it as 1/2 h. What would the derivative of 1/2 h be? 1/2. So what's the derivative of 1 over xh? 1 over x, because x is a constant, times dh dt. Okay? Then I divide both sides by secant squared, so I'm going to have d theta dt is going to be equal to 1 over x times secant squared theta times dh dt. But we're going to replace secant squared theta, so let's do that again. Let's find secant theta. Again, it's so, ka, toa. We're doing cosine for secant, but we flip it because secant is the reciprocal cosine. So we do secant theta. It's not adjacent over hypotenuse. It'll be hypotenuse over adjacent. So again, it's going to be the square root of x squared plus h squared over x. Now we're going to square it. What do you get when you square that? X squared plus h squared over what? And now I can put that in for secant, which is in the denominator again. So since it's in the denominator, you multiply by the reciprocal. So the x squared will go on top. The x squared plus h squared will go on bottom. And then you can cancel out what? You can cancel out one of the x's. So you get x over x squared plus h squared times dh dt. And they're so predictable because it looks like the answer is A again. How was that? Wasn't so bad, was it? Good stuff?
Not after you explain it. It makes sense.
Makes sense after I explain it. Good. All right. Let's go to the bookwork or the binder work.
You just told me no. It has to be like on photo paper. No, like your actual scholarship application. Oh, they're gonna not give me the scholarship.
Okay, so I gave you, let's see here. What did I give you? Linear approximation homework? All right, these are actually good. This is real good because you have to practice some derivatives. Okay?
Sorry, I'm getting contacts today.
Cool.
For softball, I couldn't see the person who was throwing the ball to me, so I was like, maybe I should go do that. The ball just...
Can't believe spring sports are starting in a week.
I'm excited. So excited.
Me too, I am too.
Next week or the week after.
Yeah, correct.
Isn't there one open during the week? You are? I'll go then.
Because I finally like have a free day.
Okay, here we go. We ready?
Yeah.
All right, this is on linear approximation. Okay, we're on linear approximation. So this is section 4.5, right?
Yep. You know, I did so good on this.
All right, so here's what you do. To do linear approximation, you have to be really good at writing the equation for the tangent line. What do you need to be able to write the equation for a tangent line? You need a point and slope. We find the point from the OG, and we find the slope from the derivative. first derivative. Okay? So we get the point from the OG, we get the slope from the first derivative. So we're going at tangent pi over 4. So let's find both. Let's find the point first. So the point would be f of pi over 4. So we're going to have tangent of pi over 4. What's tangent of pi over 4 on the unit circle? 1. So we have our point. So it's pi over 4 comma 1. All right, so there's the point. The slope, we use the first derivative. So what we got to do is we got to take the derivative of this. So let's take the derivative. So what would that be? Secant squared x. Okay? And then the derivative of x is just 1, so you don't really need chain rule. All right, so then we got to find f prime of pi over 4 to figure out our derivative at pi over 4. So we're going to have secant of pi over 4, and you're going to take that answer and square it. All right, what is secant of pi over 4? Secant's reciprocal cosine. So what's cosine of pi over 4? It'd be root 2 over 2. But so that's cosine, right? Cosine of pi over 4 is root 2 over 2. But then you got to flip it. So what's secant of pi over 4? Well, yeah, but we should have this memorized. So what is it? Root 2, thank you. It's 2 root 2 over 2 with the 2's cancel because you have to get rid of the root on the bottom and all that stuff. So it's going to end up being root 2. Like if you, so cosine of pi over 4, I'll do this, but you should have this memorized. It's root 2 over 2. Secant of pi over 4 would just be that flipped. Yes, it's going to be 2 over root 2, but then you end up with 2 root 2 over 2. So it ends up being root 2. Okay? I just have those memorized. Those are reciprocals of each other. So it's root 2. So you're going to take root 2 and square it. What's root 2 squared? 2. So we take the point and the slope and we create, so it says find the tangent line approximation. We're just going to call it L of x when we're done. So we're going to have our equation will be, I'll do that by, it'll be y minus 1 equals 2 times x minus pi over 4. And remember the tangent line approximation, they want you to set it equal to y and relabel it L of x. So that's the only extra piece here. And it's not, it's really just saying we're going to use this to approximate something. So it would be y equals 2 times the quantity x minus pi over 4 plus 1. And it really doesn't matter to me if you forget to relabel the y as L of x, whatever. But it is, they call it L of x. The linear approximation. But it's just the tangent line is all it is, set equal to y. So there's my linear approximation. Yeah, not bad at all. It's just doing tangent line. The thing that I like best about this,
I looked at it and I was like, what do I start?
the best thing I like about this is you're going to practice doing derivatives. Okay, so let's do it again. Point, let's do point, and let's do slope. So we need point and slope. Let's do point first. So it'd be y of 1. So we're going to plug 1 in. So that'd be e to the root 1. What's root 1? 1, so it's just going to be e. So y of 1 is e, so that's the point 1 comma e. Okay? Okay, so slope. So you're going to have y prime. You need the derivative. So what's the derivative of e to the root x? This is good review. How do you do the derivative of e to the u? Let's review this. Derivative of e to the u. And that's on your quiz today, so you should have that memorized. E to the u times du dx or u prime. Okay, so it's itself times the derivative of the exponent. All right, so what is the derivative of e to the u? It'll just be what? E to the root x times the derivative of root x, which will be what? 1/2 x to the negative 1/2. Okay? So we'll have y prime is going to be equal to you know, it'd be, if you multiply this together, it'd just be e to the root x would go to the top, and the 2x to the 1/2 would go to the bottom. Not that you really have to simplify it, but you probably do a little bit so that you can plug in your 1. Okay, so my derivative, y prime of 1, is going to be e to the root 1 over 2 times 1 to the 1/2. Well, nice thing about 1s is they stay what? 1s. So we're going to have e over what? 2. So there's your slope of your tangent line. So then my equation would be, here's my point, here's my slope. So it'd be y minus e is equal to e over 2 times x minus 1. Set it equal to y, so it'd be y equals e over 2 times x minus 1 plus e. And then just change it to L of x. L of x is equal to e over 2 times x minus 1 plus e. Good stuff. All right? Number 3, might as well do them, right? All right, g of x. You guys came in early. I might as well do them, right? So we're going to have, what would you do to take the derivative of this?
Take that to the negative 1.
I'd use chain rule. I'd take that to the negative 1/2, so I could use chain rule and not quotient rule, because the top is a constant. So we're going to have 1 times 1 plus x to the negative 1/2. Yes, I would definitely use chain rule to do the derivative of this. So bring it to the top so I can use chain rule. And that works really well when the top is a constant. Now, if the top's not a constant, you would have to use what? Then you have to use quotient rule. All right, so we're going to have g prime of x is going to be equal to negative 1/2. Negative 1/2 times 1 is negative 1/2 times 1 plus x to the what? Negative 3/2. And then what's the derivative of the inside? 1. So that don't really matter. Okay, so we're going to have negative 1 over 2 times 1 plus x to the 3/2. All right, so there's my g prime of x. Now I can plug in 3. And this is, again, this is finding slope. So we're going to have g prime of 3 is going to be equal to 1 over 2 times 3 plus, sorry, not 3 plus, 1 plus 3 to the 3/2, which will give me 1 over 2 times 4 to the 3/2. How do I do 4 to the 3/2 power? I just taught my 9th graders how to do this yesterday. They were like, wee. Huh? You can do either order. I always do the root first.
Yeah, so then it's 2 times 3.
Forget the negative, or does it?
No, then, I did forget the negative. Thank you. That negative does have to come down.
I don't know, sometimes I think.
No, it did not cancel out. That negative is there. I apologize. All right, so which one should you do first, the cubed or the square root? I always do the root first because it makes it smaller. So what's the square root of 4?
2.
What's 2 to the 3rd power? 8. So we're going to have negative 1 over 2 times 8, which is negative 1 over 16. So there's my slope and my tangent line. Now, what have I not done?
Find the point.
Got to find the point. The point, it's nothing but the point. Come on. All right, 1 plus 3. It's 1 over the square root of 4. What's the square root of 4? 2. So it's 1/2. The point is 3 comma 1/2. So we've got our slope, which is negative 1/16. We've got our point, which is 3 comma 1/2. So we have the point and nothing but the point, so help you God. So now we can write my equation. It's to be y minus 1/2 is equal to negative 1/16 times x minus 3. Solve for y. We'll have y equals negative 1/16 times x minus 3 plus 1/2, and then change it to L of x. So L of x is equal to negative 1/16 times x minus 3 plus 1/2.
Can you just change it to
You can change it to L of x as soon as you set it equal to y. Okay? And it really only matters on the free response. If it's on the multiple choice, they're not going to see your answer anyway, so who cares what you do? If you leave it as y's, it's fine. Because then you're going to actually use it to approximate like a decimal close to 3, like 3.1 or 3.2 or whatever it is. Okay? All right. Oh, good review here. How do we do slope? All right. Well, you have your rule today. Does anybody remember the derivative rule for inverse tangent? I hope.
U prime over 1 plus u squared.
Yep, inverse tangent of u would be, I like it like this. I go 1 over 1 plus u squared times u prime. But a lot of people, like Logan, memorize it with the u prime on top. That's pretty normal. So u prime over 1 plus u squared. So the inverse derivative for tangent is 1 over 1 plus u squared times u prime. All right, so derivative. So y prime. So since this is an x, it's just going to be what he said. It's going to be 1 over 1 plus x squared. And then the derivative of x is just what? 1. So do I need to write that 1? You can if you want, but you don't need it. So if I want the derivative at 1, it's just going to end up being 1 over 1 plus 1 squared, which will just end up being what? 1/2. So there's your slope. And now I'm going to take the derivative. Or I did take the derivative, sorry. I'm going to do the point. I'm going to do the OG now. So I'm going to plug 1 into this. Okay, this is good. Okay, y of 1. So our point, we're plugging into the original equation. This is really good. We got to do inverse tangent of 1. All right, you got to do the reverse unit circle. Inverse tangent, you got to do reverse. You need to figure out where tangent equals 1. Pi over 4. Because that's where, because remember, tangent sine over cosine, and you need sine and cosine to be equal. So you can't do it like a root 3 over 2 and a 1/2, or a 1/2 and a root 3 over 2. You need them both to be root 2 over 2, and that happens at pi over 4. So your point is y of 1 is equal to pi over 4, so it's 1 comma pi over 4. So we got our point, we got our slope. Write the equation. So we're going to have y minus pi over 4 is equal to 1/2 times x minus 1, and I'm going to take Autumn's suggestion, and when I set it equal to y, I'm going to go ahead and change that y to what? L of x. So I'm going to have L of x is equal to 1/2 times x minus 1 plus pi over 4. Pretty easy, isn't it? Now let's actually apply it, because that's probably like a multiple choice question. Just find the equation of the tangent line. And they might actually go a step further and say, use the tangent line to approximate it at 1.1. Then what would you do? After you find this, what would you do? Plug in 1.1 and know that means it's an approximation for y of 1. They called it y. So y of 1 would be the approximation if you plugged it into L of 1. That's what that means. Like if you use this to approximate y of 1, or sorry, not 1, y of I take that back. You wouldn't do y of 1 because you know what y of 1 is. You would do like y of what? 1.1 or 0.9, something like that. You'd pick something close to 1. Okay? All right, last 2. And then call it good. And then study for your 54 things. Okay? And if you got any other. Yeah, same ones are extra credit. Some of them are extra credit. Okay. Let f be a differentiable function such that f of negative. Now, I love these because this is probably most likely a multiple choice question because they actually do most of the work for you. Because when they tell you f of negative 2 is equal to 3, what is that? That's your point. And then this is your what? Slope. So the tangent line at the graph of negative 2 can be used to find an approximation to a 0 of the function. And I'll explain that. That's actually pretty straightforward. Let's write the tangent line approximation equation first. Do we have the point? Yep. Do we have the slope? Yes. So let's write it. So it'd be y minus what? 3 is equal to 6 times the quantity x plus 2. So if I solve for y and change it to L of x, it'd be L of x is going to be equal to 6 times the quantity x plus 2 plus 3. Now it says, what do they want us to use this for? It says the tangent line to the graph at negative 2 can be used, so it's saying it can be used to find an approximation for the 0 of a function. What's the 0 of a function? When it crosses the x-axis. What do you do when you want to see if something crosses the x-axis? You set it equal to what? So you're going to set the tangent line to equal to what? 0. So you're going to set this equal to 0 and solve. So it'd be this, which will be easy. because I can subtract the 3, so I get negative 3 is equal to 6 times x plus 2. You can either distribute the 6, or you can distribute it if you want, or you can just divide by it. I don't care. So you're going to have negative 3 over 6, so I'm going up to here, is equal to x plus 2, which is negative 1/2 is equal to x plus 2. Subtract the 2 from both sides, and what do you get?
5/2.
Negative 5/2 or negative 2.5. So that would be an approximation for the 0 of the function. And the reason you would do this is because maybe you don't know what the original equation is.
Wait, so do we have to do this squiggly line or no?
Yeah, it should be x is approximately, thank you. It was an approximation, you're correct. All right, for the linear approximate, now this is definitely something good here. It says for f of theta, use the linear approximation to estimate point A and then find the error. Okay, last problem. All right, first of all, let's find the point. How do we find the point? This is really good. So we go f of pi over 4. So we're going to have sine of pi over 4 and then do what to it? And then do what to it? Square it. What's sine of pi over 4? Root 2 over 2. So you're going to have root 2 over 2, and you're going to square it. What is that going to give you? 2 over 4, which is 1/2. So there's your point. I'll be with you in a minute. I'm almost done. Okay, there's my point. Now we need our slope. So I'm going to have f of theta. So this is slope now. F of theta is equal to sine squared of theta. All right, let's take the derivative of that. So what would the derivative be? What rule do you got to use? Chain rule. So what's the derivative? What's the outside function for this? The squared. So you're going to have 2 sine theta times what? Times cosine theta times 1. So there's my derivative. I don't really have to put the times 1, but I just do it to remind you you're using the chain rule. And then I plug in pi over 4. So I'm going to have f prime of pi over 4, which is going to be 2 times sine of pi over 4 times cosine of pi over 4, which is kind of nice because we already know what sine of pi over 4 and cosine of pi over 4. Even Michael does. Okay, sine of pi over 4 and cosine of pi over 4 is what? Root 2 over 2. So we're going to have 2 times root 2 over 2 times root 2 over 2, which we just figured out what root 2 over 2 times root 2 over 2 is. What is that? 1/2, 2/4, or 1/2, because root 2 times root 2 is 2. 2 times 2 is 4, so you get 2/4, which is 1/2. But then I have a 2 times 1/2, so what is it? The slope of the tangent line is 1. So we got my point and we got my slope. Is everybody with me? Almost done. All right, so now I write my equation. So what would the equation be? Y minus what? 1/2 is equal to 1 times the quantity x minus pi over 4. So then my linear approximation equation would be L of x is going to be equal to 1 times x minus pi over 4 plus 1/2. And then they want you to linear approximate. So we got your linear approximation equation, correct? So they want you to approximate at 0.8. Let's make 0.8 a fraction. What is 0.8 as a fraction? 8 over 10, which is 4/5. Do you agree?
Yeah.
All right. So let's plug it in. So it'd be 1 times 4/5 minus pi over 4 plus 1/2. What's the common denominator for 4/5 and pi over 4? It ain't super. 20. So you're going to have 5 over 20. Let's see. No, it'd be 16 over 20 minus 5 pi over 4 over 20. Is that correct? Or sorry, 5 pi over 20? Because you got to multiply the first one by 4, so that's 16 over 20, correct? And then we're going to have 5 pi over 20. So we're going to end up with, here it is, it's going to be 16 minus 5 pi over 20 plus 1/2. And I'm not going to make you find the common denominator for that, but that's the linear approximation. So L of 0.8 would be approximately f of 0.8. So there's the approximation from point 8. Now, does it over or underestimate? What would you have to do to figure out if it over underestimates?
Either the third, second.
You got to go to the second derivative. You'd have to go to the second derivative, so you'd have to take the derivative of this. We're not going to do it, but what would that require? Product rule. Then after you find the second derivative, you would have to plug in pi over 4. If it's positive, it's concave what? Up. Then the tangent line is below, and it would under. If you plug in the second derivative and it's negative, it's concave what? Then the tangent line's above, and it would what? Over approximate. There you go. Can I post what? Yeah, I'll post the turn-in spot.